Yo guys, what's up? Welcome to a new video on my channel, and today I will explain how to convert a decimal number to a binary number thanks to the Euclidean algorithm. And today I will explain you how the Euclidean algorithm works and how to solve it in JavaScript. So firstly, I'm going to explain you how the Euclid algorithm works in theory, and then I will code it in JavaScript so you will see both sides. Yes, so now we switch on paper, and the Euclidean algorithm will now be explained with the test number 193. So what we will have to do is we'll have to write down the number. So 193 divided by 2 equals to 96, and the remainder will be 1, because we obviously can't divide this number by 2, and that's why the remainder will be 1 when dividing by 2. So the next number will be 96, so we will take the result from before, put it down here, and we will divide it also by 2, and we will repeat this process until we arrive at 0. So this equals 48, but without a remainder, so remainder is 0. The next number, obviously, 48 divided by 2 is what? 24. And instead of writing all the time remainder, we will just do the double quotations here, and the remainder is 0 because it's clean, we don't have an odd number. But now we will have 2 divided by 2, no, 3, so sorry, 3 divided by 2, and that equals 1 because the 2 just fits one time in the 3, so we will end up with a remainder of 1. And now to go to the number 0, we will have 1 divided by 2, that equals 0 with a remainder 1, and this is the binary number here. So how we will write it down is from the bottom to the top. So the binary number will be 1 1, so 1 1 1 2 3 4 5, so 5 0, so 1 2 3 4 5 and 1 1. So the number 193 equals in binary to 11000001. Yeah, this was the Euclidean algorithm on paper. I hope you got it, and I hope you got this whole algorithm, and now we will code this whole process in JavaScript. So back in the editor as usual, we are now going to code the Euclidean algorithm, and let's start. So we will write a function of the Euclid algorithm, or yeah, this fits, equals to n. This means the number, like for example a 193, the number that I used in the paper example. And now we will have to declare some variables. So at first we are going to declare the binary number. It will equal to 0. Then we will need the remainder. Yeah, we can write it out, so as remainder. Then we will need I equal 1, and we will need the steps. So we want to display the steps in the console outsole. So while n is not 0, You saw in the paper example that in the Euclidean algorithm it ends when it equals to 0. So while n isn't 0, we want the remainder equal to n modulo of 2, and we will console log these steps. So we will use a variable string, so we can put in these whole variables here. So the console will always show step 1 or step 2. So in order to show every time a step higher, we will have to increase the step variable, so step plus plus. Then we will need to show that the given number is being divided by 2. So we will write in $ and curly brackets n divided by 2. And we will show the remainder, and it will equal to $ curly bracket the remainder. And what we will also want to show is the quotient, so it will be $ curly brackets, and we will not parse float but parse int n divided by 2. So this for console logging at first. Now in order to actually write the binary number, so n will be equal again to parse int 2, so n will be divided by 2, just like here, and the binary number will be equal to the current binary number plus the remainder times I, and I will be equals to I times 10. So now what we will need to do is to console log the binary number, but we also have a final result, so console.log, and we will also need variable strings here because we want to show the binary variable here, so binary $ curly brackets and the variable binary. Yep. So this was it. We will just have to declare the numbers, so let n be like the example that we wanted to use, be 193, and we will call the function with n, and let's start it. So node run code.js, and our result is right. This is the same result that we got on paper. So I will show the result on paper here. And yeah, so we will go through it. So step 1 is 193 divided by 2. It has got a remainder of 1, and the quotient is 96. This number, so this quotient, will be used in the second step, and it will be again divided by 2, and the remainder is 0. The quotient will be 48 because 96 divided by 2 is 48. And this will go on until we will reach 0. Here, while n is not 0, this function will go on. So when it reaches 0, it will stop, and as I've mentioned earlier, from the bottom to the top. The binary number will go from the bottom to the top, so 1 1 0 0 0 0 0 1. Here you can see it on paper again. So to make a second walkthrough through the code, this code defines a function, Euclidean algorithm, that converts a decimal number n to its binary representation using the Euclidean algorithm. And let's again break down the code step by step. So The Euclidean algorithm function only takes one parameter, n, which is the decimal number which will be converted to the binary number. Inside the function, binary is initialized to 0, which will hold the binary representation of the decimal number. Remainder is declared to hold the remainder of the division. I is initialized to 1 and will be used to calculate the binary representation by powers of 10. Step is initialized to 1 and will be used to track the steps in the conversion process. So the whole loop runs as long as n is not equal to 0, indicating that there are more bits to process. The remainder is here calculated by finding the remainder of n divided by 2, and the console log message is printed to the console indicating the step number, the division of the numbers by 2, the remainder and the quotient, and is updated to the integer division of x by 2, and the binary is updated by adding the remainder multiplied by I, which effectively builds the binary number. I is multiplied by 10 to prepare for the next binary digit. Once the while loop completes, all the binary digits have been calculated and the resulting binary number is logged to the console. Finally, the function is called with the number 193 here. So when running it, we have this result. The while loop runs 8 times. So in order to prove that the function iterates 8 times, we will have to write in a calculator log from 193 to the base of 2 equals to 7.5, which when we round it up equals to 8. So as we can see, the loop goes up to 8. So during each iteration, it logs the division step, the remainder and the quotient. At the end, it prints the binary representation of 193, which is 11000001, and this was the whole code here and the whole video. So I hope you liked the video. If you liked it, leave a like and comment what video I should do next, and I will see you in the next one. Bye.